Welcome to our next lesson in graphing lines, and you'll notice that this lesson also has a bunch of asterisks after the title because it is that important. So this lesson and the previous lesson in this series are really foundational to larger concepts in math. So you might want to bookmark them or watch them more than once, or make sure that you have extra problems coming from another website or another video series to supplement this. I just really want to draw your attention to the fact that this is really important. So the concept of the slope of a line is foundational, and you will use this concept all the way through calculus. So you can't really pay too much attention to it. So I wanted to start by going back to graphing lines by plotting points and back to the fact that we observed some patterns with that. And what I did right here was I took the equation y equals 2x plus 1, and just to save some time on a really important lesson, I went and filled in the table for this. And I just started with x is equal to 0 and went to x is equal to 5. So we have 6 points, right, 6 points. And what you should notice is if you have a pattern to your x's, there is a corresponding pattern in the y's. And with linear equations, that pattern will always be the same kind of pattern. If you have a different equation, there'll be a pattern as well. It'll just be a different kind of pattern. If your x's don't have a pattern to them, so if you're kind of picking x's all over the place, then it'll jumble up the pattern with the y's, so you won't see it, but it will still be there. And so with this one, what we notice is that whenever I go up by 1 on the x's, I'm increasing the y by 2. And so I add 1, and then 1 plus 2 is 3. Add 1, 3 plus 2 is 5. Add 1, 5 plus 2 is 7. So I wanted you to notice something. We're going to look at the ratio of the y's to the x's. So if I were to pick, say, this point and this point, and I were to subtract those y's, so I do 7 minus 3, and then do the corresponding subtraction. So I'll start with the bottom number and go to the top. So 3 minus 1. 7 minus 3 is 4, and 3 minus 1 is 2, and 4 divided by 2 is 2. Now, let's just say I pick some different points. So let's say I pick 4 over 9. It would jump all the way back to the 1, 0. Or 4, not 4 over 9, but 4, 9. So I'll do the same thing. I'll do 9 minus 1 over 4 minus 0, and I end up with 8 over 4, which equals 2. And we'll just do one more. We'll do the 5, 11, and we'll go back to the 1, 3 again. And so we'll do 11 minus 3, and we'll do 5 minus 1. And so once again, I end up with 8 over 4, which, no, 8 over, what did I just do? I put a 4. I did the subtraction in my head as I was writing it down. There we go. And just to show you that it works in a different direction, we haven't used the 2, 5 yet. So let's do the 2, 5, and this time we'll jump down to, we'll just jump down to the 3, 7. So I'll do 5 minus 7. We'll just go in the other direction, and 2 minus 3. And 5 minus 7 is negative 2. 2 minus 3 is negative 1. And of course, a negative divided by a negative is a positive. So what I want you to notice in that, looking at that table, is that if you pick any 2 points on that table, any 2, and you subtract the y's and you subtract the x's and you take that ratio, you get the same number every single time. So we're going to take a look at that same thing from a graphing perspective. And what this is doing is this is establishing the idea of slope. So I copied the table over here, and we'll just do a quick graph here. So we have the point 0, 1, the point 1, 3, the point 2, 1, 2, 3, 4, 5, the point 3, 7, the point 4, 9, and I just went off the edge of my coordinate plane there. And then we know that those are not the only points we can pick, and so we connect them with a line. We put the arrows on the end. Now, the way this looks graphically is we look at that vertical change over the horizontal change. So over here, I was looking at the y's on the top, and then I was looking at the x's on the bottom. So we're going to do the same thing. if I were to look at the change from, say, this point to this point, I would go up 1, 2, 3, 4. Okay, I went up 4 and over 2. 4 over 2 is equal to 2. So we see that number coming up again, like 4 over 2 is 2. If I were to pick this point and this point, okay? Now let me erase there we go. Now I'm going up 1, 2, 3, 4, 5, 6, and over 3, and 6 over 3 is 2. What if I pick this point and this point? Well, I'm going up 1, 2, 3, 4, 5, 6 again, and over 3, 6 over 3 is 2. Okay, and what we want to notice, and like even if I were to pick like points down here, any 2 points on the line, any 2 points at all, if you take the vertical change and compare that to the horizontal change, so you do vertical over horizontal change, that number is always the same number. And that number is referred to as slope. Now, we can informally define slope as the steepness of a line. And you're familiar with that from like watching skiing on the Olympics or something, that you could have something that is not very steep. You could have something that is very steep. You could have something that is super, super, super duper steep. You could have it be steep, but in the other direction. So pretty much what we're talking about here is we're talking about a number that quantifies exactly how steep the line is. The bigger the number, the steeper it is. I should be more precise. The bigger the absolute value of that number, the steeper it is. Now, the symbol for slope is a lowercase m. And I have a lot of students that like still will kind of not get that right. I don't know. When I was taught it, we were taught like M for mountain, and mountains have slope. So the symbol for slope is M. And there is a formula for it. So if you have 2 points, okay, we're going to clear up a little confusion, all right? The problem with writing an equation from this, all right, or writing a formula is that I have 2 x's and I have 2 y's, and I have no way to keep them separate. So I've got like an x here and an x here, but they look identical, and that's problematic. So what we're going to use here is something called a subscript. The prefix sub, you want to think below or under, okay? Like a submarine. Under, that's an R. And so you got like your water, and you have like the boat on the water, okay? And underneath is, I don't actually know what a submarine looks like, but the submarine is underneath, okay? So that should help you remember what like a subscript is. And so a subscript is it could be a number or a letter. We use them all the time. That's written just below the level of the letter. And so what we do is we're going to put like a 1 right there and a 2 right there. And what that just signifies is 0.1 and 0.2. Okay? And that's all that subscript means. And the way we would read this is x sub 1, y sub 1. When I took Algebra 1, I could never understand my Algebra 1 teacher because he said x sub 1, y sub 1, and I had no idea, and I was not going to ask because I don't ask questions in class. So I went my whole 8th grade year. I didn't know what I was doing. I didn't know what he was saying anyway. I could do it. I just didn't know what he was saying. So he was saying x sub 1, y sub 1, x sub 2, y sub 2. And all that is a way to distinguish between the x's and the y's so they don't look the same. Here's the formula. The formula for slope is the difference in the y's. So remember, the word difference means subtract. So you take the 2 y values and you subtract them. And then you divide that by the difference in the x's. Star this. Make sure you write it down. You're going to write it down a million times or you won't remember it. And that is what I was essentially doing right here. I was subtracting the y's and subtracting the x's. Now, a couple of things to remember. You do have to keep them in order. So it's going to be like the y coordinate of one point minus the y coordinate of the other. And then you have to keep them in the same point order. So you can't like flip flop the subtraction. Another common mistake that I do see is I'll see students put the X's on the top. Okay. A shorthand way that that people will often refer to this is they'll call it like rise over run. And so you will hear that a lot, and a lot of you might be familiar with it. And that's because when you're looking at the line and you've got the 2 points on the line, the up and down is considered the rise, and then the run is your back and forth. And it just has this nice alliterative value to it, like, oh, rise over run, and everything starts with an R, and it's really nice. Now, it doesn't matter how you pick which point is point 1 and which point is point 2. You just can't change your mind partway through it. So we're going to walk through 4 examples. So this is going to be another fairly long lesson because it is so important. But it's worth it to really make sure that we're clear on all of what slope is and the different variations you can see. So we are going to solve this problem here. So find the slope of the line going through. You might also hear the words containing, would be another way to say that. -2, 0, and 3, 1. All right. And so I always encourage my students to be able to approach problems from different angles. And so we're actually going to approach this 2 different ways. We're going to look at it graphically, and then we're going to apply the formula to it because we want to have that flexibility to do either or. So if I plot -2, 0, and I plot the point 3, 1, all right, I should be able to see what that line looks like. Now, I can actually get the slope from the graph, because slope is the vertical change between the points over the horizontal change. So my rise is going up 1, and it's going, and that's up, so it's positive, and then it's going 1, 2, 3, 4, 5 over to the right. So the slope is the vertical change over the horizontal change. The slope is 1/5. But we also want to be able to do this with the formula. So remember, our formula is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And if you are new to slope, I strongly, strongly encourage you to copy that formula down every single time you do a problem, because this is one of those, like, have to know it, have to remember it, cannot fall out of your brain. Now, what we have to do is pick point 1 and point 2. So it really truly doesn't matter. So I'm going to pick this to be point 1 and this to be point 2. And then I should be able to do a straight substitution. So y2 is 1 minus y1, which is 0. x2 is 3 minus, and here you want to be really, really careful. There is a minus inside that formula, but there's also a minus attached to the x1 value, okay? So this is going to be 3 minus -2. And this is why it's so important that you're good with your signed numbers and you're okay with the idea of subtracting a negative. And when you see this, you have like your moment of like, oh, really? I have to deal with 2 negatives. And then you take a deep breath and you say, okay, I got this. All right, so 1 minus 0 is just 1. And then remember, 3 minus -2 is just an awful way of writing 3 plus 2. And so 3 plus 2 is 5. And what you should notice is that you get the same answer whether you're obtaining it from the graph or obtaining it from the formula. Now, I'm only going to do this last part one time because it's not the kind of exercise that we really want to do all the time. But I did mention that it did not matter which way you picked point 1 and point 2. And so just as the exercise here, I'm going to do this out in the other direction. So I have y2, which now is 0, minus y1, which is 1, over x2, which is negative 2, minus x1, which is 3. 0 minus 1 is negative 1, and negative 2 minus 3 is negative 5, and a negative divided by a negative gives you a positive. So I don't really want to work it out both ways every single time, but I do want to do it at least once to show you that it doesn't matter which order you pick, point 1 and point 2. What's key is that you don't change your mind halfway through the problem, and you don't do 1 minus 0 over negative 2 minus 3. Okay, because that will give you, it'll flip the sign of your slope. But you can get it from the graph, or you can get it plugging in either way. And what I want you to notice is this: a positive slope, the line tilts up from left to right. Okay, pause the video, make sure you write that down. So if the line is tilting upward, it means your rise is positive and your run is positive. Or if you go the other way, your rise is negative and then your run is negative. So you're going down and you're going to the left, which would ultimately give you a positive. If your line is tilting this way, it's always going to come out like that. And so positive slope means that your line tilts up as you move from left to right. All right, let's do the next one. So we have find the slope of the line containing negative 1, 2 and 2, 2. So again, we're going to approach all of these with the graph and with the formula because it's so important that you're connecting the two together. So we have the point negative 1, 2, which is right here, and the point 2, 2, which is right here. And what you should notice about that is that that is a horizontal line. And if you try to do the vertical change, like we did over here, you've got that vertical change. We did it back here. I don't even know where. Here we have a vertical change to get from one point to the next. You'll notice that in this one, there is no vertical change. The vertical change is 0. The horizontal change is 1, 2, 3 units. And so we have 0 units up. And 3 units over, 0 divided by 3 is 0. So let's just see how the formula confirms that. Again, strongly recommend that you copy that formula down every time. You can time how long it took me to do that. It does not take a long time. Write it down. Let's go ahead and we'll pick, I'm going to pick, this is x2, y2, and this as x1, y1. And we'll go ahead and plug it in. So y2 is 2, y1 is 2, x2 is negative 1, minus x1, which is 2, and 2 minus 2 is 0, negative 1 minus 2 is negative 3, and 0 divided by negative 3 is 0, and so we notice that they match. So a horizontal line slope is 0. The actual number 0. Don't say it has no slope. It has a slope. The slope is 0. Okay, next one. Find the slope of the line passing through 0, 0, and 1, negative 1. I do want to point out, notice it says the slope of the line. It doesn't say the slope of a line, because once you put 2 points on that coordinate plane, there's only one line that goes through both of those points. So let's go ahead and plot them and see what this looks like. So we have 0, 0, and 1, negative 1. And what we notice in this example is that the line is tilting the other way. Okay, so instead of going up in this direction or being horizontal, now it's like we're rotating it around and it's going the other direction. So let's do this with that change, okay? To get from one point to the other, I go down 1, and down is the negative direction. And so we go down 1, and then we go right 1. And so that vertical change is down 1. The horizontal change is positive 1, and negative 1 over 1 is negative 1. Let's confirm that with the formula. I'm going to keep saying it. I strongly recommend that you write down this formula for every single problem. All right, let's do x1, y1, and x2, y2. Now, really experienced problem solvers do not label the points 1 and point 2. So if I were doing these and I wasn't presenting the instruction, I would not write those, okay? I would just go ahead and plug them in. And you can do that too as soon as you're comfortable. So y2 is -1, y1 is 0, x2 is 1, and x1 is 0. -1 minus 0 is -1, and 1 minus 0 is 1, and so we get -1 for the slope. And again, you know, what we get from the graph and what we get from the formula should match. And what you want to remember from this is that a negative slope means the line tilts down from left to right. So just think of the way we read in English. We read from left to right. So as you go across the line, we're tilting down in this example. So negative slope means that it is tilting down. All right, one more example. Right, this last one, find the slope of the line going through 2, 1 and 2, 4. So we're going to look at that. 2, 1 is right there, and 2, 4, 1, 2, 3, 4 is right there. And so we recognize this as a vertical line. Now, here's the problem with doing the rise over the run, or that vertical change over horizontal change. The vertical change between the points is 1, 2, 3 units. But the horizontal change, is 0. You don't move at all. And so we end up with 3 divided by 0, which is undefined. It is an undefined mathematical operation. You cannot take 3 of something and put it into nothing. Okay, that involves a break in the space-time continuum. Okay, so we're not doing that. Now, if you use the formula to do this, we have like x1, y1, and x2, y2. And we have the formula, which is x2, y1 minus, or y2, y1 minus x2, you know what I mean. y2 minus y1 over x2 minus x1. And we go to plug this in, so we have 4 minus 1, sorry about that, 4 minus 1 over 2 minus 2, and you'll notice that we get the 3 over 0. So vertical line, we say the slope is undefined. Do not say that the slope is 0, because it's not. Okay, the slope of 0 was the horizontal line. Slope is undefined. Dividing by 0 is an undefined mathematical operation. It is not equal to 0. Grab your calculator and throw it in there and do 3 divided by 0, and it's going to give you some kind of error message where it's very, very unhappy. Last thing I want to mention before we get to the practice problems is just what's called like the magnitude of the slope. So the bigger the number, okay, and again, this is like the absolute value of the number, the steeper the line, okay? So as the slope increases, the slope is getting greater. Now, right here is where you have that undefined slope, and the moment the line is tilting this way, now it has the negative slope. If you have a line tilting in the positive direction, I don't know what I'm doing here. Let's do this. Okay. So we have a line with a slope of 2. Oh my gosh, I keep opening up a new window with my hand. And then you have a line with the exact same steepness on the other side. This would have a slope of 2. This would have a slope of -2. They have the same steepness, but they're tilting in opposite directions. So just something to keep in mind with that. So as always, I'm going to put some practice problems on here, and you should pause the video, try them out on your own. You cannot practice this too much, okay? That's not a possible thing. Practice it too much. Lots of little places where you can make mistakes. Once you've tried them, unpause the video and then check your work and then make the corrections to your work as needed. All right, for the first 5 problems, you are to plot the points and find the slope from both the graph and using the formula 0, 0, and 4, 5, -3, 2, and 1, 6. Oh, -3, -2. Sorry, -3, -2, and 1, 6, 0, 6, and 8, 0, -6, -1, -6, and -6, 4, 1, -2, and -2, -2. And then for number 6, find the slope of the line containing 2.253 and 1.75, -4.12. And that last one is just to emphasize that you don't always want to rely on finding the slope from the graph. You should be able to do it from the graph a lot of the times, but not all the time. Sometimes you have to use the formula. So pause the video, try these problems out, and then unpause to check your work. All right, let's take a look at this. So the first one, we were doing the points 0, 0, and 4, 5. And so the slope of the line is 5/4. And it's totally okay to leave that as a fraction. Don't change it to a mixed number. Sometimes you'll see slopes change to decimals. It depends on what you're going to do with them, but definitely don't need a mixed number. So if you change it to 1 1/4, kind of draw a little line through that and just kind of write like a note to yourself, I don't need to do that. Second one, and with any of these problems, pause on the slide as long as you need to in order to get, to make a correction to your solutions. For the next one, we had -3, -2, and the point 1, 6, and the slope of this line is 2. And you should be able to get it both from the rise over the run, from the graph, and from the formula. Your work might look different from mine. So you might have +8 over +4, and that's okay. They end up in the same place. All that means is that you picked your point 1 and point 2 differently from how I did, and that there's no mistake, so don't think that there's anything wrong with that. All right, next one, we had 0, 6, and 8, 0. And so this one should be -3/4. If you stopped at -6/8, you didn't simplify the fraction. And I wasn't really explicit about you needed to do that. So if you didn't do that, make that correction. Now just say like, oh, don't forget to simplify the fraction. Now, the other thing that might happen with this, and this will sometimes throw students, is you might have 6 over -8. And that is totally okay. The placement of the negative does not change the correctness of the answer. So you might have 3 over -4. Remember that a negative divided by a positive is a negative. A positive divided by a negative is a negative. Both of these, if you threw them into your calculator, would give you -0.75. Okay, they are equivalent. So if your negative's in a different spot, don't worry about it. No mistake there. Next one was a vertical line. Make sure that you have the slope as undefined, and do be careful with your double negatives over here. You have the negative in the formula, and then you might have the negative coming in with the number that you're substituting in. So be really, really careful about that. It's an advantage to graphing. If you graph it and you know it's vertical, then you know it should come out as undefined when you use the formula. So you can use one strategy to check the other. The next one is horizontal. So we have 1, -2, and -2, -2. So you should have 0 divided by a number. I ended up with 0 over -3. You might have 0 over +3, but it doesn't matter because they're both 0 in the end. And again, if you graph it and you know it's horizontal, then you know you should be getting 0 for your slope. So you can use that as a check on your arithmetic. Pay attention if you're getting them wrong and see if you can identify why you're getting them wrong. Are you plugging in the numbers in the wrong spot? Is your fraction upside down? Are you making an error with the positives and negatives? Because if you can diagnose where you're making the mistake, that's the first step to fixing it. The last one, I deliberately threw you some stuff that wouldn't be great to do with the graph, and that's why we have the formula, because sometimes our numbers are decimals, sometimes they're fractions, and sometimes they're just downright messy or they're too big to put on a graph. And so you should, at the end of this, end up with the slope is 14.24. So double check that. Again, this is a super important lesson. So rewatch or redo as much as you need to, and we'll use it in the next lesson to graph lines.